Welcome to this video on domain and range of a function. So the first part will talk about domain and range of a linear function. Next part will be on domain and range of a quadratic function. So first, we'll recall the definition of a domain. So you have it right here in front of you. The domain of a function is the set of all real x values, which we'll call input, that will make the function work. So in other words, when I select an x value and plug it into the formula, I am anticipating to get a workable number as a result. So take a look at this set of equation of a line. So the first one here, marked, highlighted, is the y-intercept slope form formula. So m represents the slope, in other words, the direction of the line. B is the y-intercept. You may come across this type of equation, standard equation of a line, where you have integers for a, b, and c, and actually a and b represents the vector that is perpendicular to the line. The next one below, x-intercept and y-intercept form. So this is the equation that immediately gives you the x-intercept value and y-intercept value. And the last one, the vector equation of a line, where d represents the direction vector, t is the parameter, x is a 0, y0 fixed point, and x and y represent those points that would be generated by selecting a value of t. So in any case, by selecting a value of x, you expect to get a workable value of y. So intuitively, in the case of a straight line, you can predict with great accuracy that I can get any x value along x-axis for which there will be a representative on y value axis. So any point on the line is well defined. So there should be no restrictions here. For any x value selected from the set of x real numbers, there should be a y number. So we can say that the domain for any type of linear function is x is element of R, which represents the set of real numbers, and in terms of the range, y is element of R. My symbol, it's getting closer now. Okay, y is element of R. So this is the domain, and down below you see the range. And now we will move to define domain and range of a quadratic function. Okay, quadratic function. So there's two types of equations that are selected here. So the standard form, so y is equal ax squared plus bx plus c. A represents the coefficient that defines the direction of the opening of the graph. So this is the standard form right here, and next one to the right you will see a vertex form formula. So the vertex has coordinates h and k, and a plays the same role as the coefficient in standard form. So when a is positive, so when a is greater than 0, the parabola opens up, which means the vertex is at the bottom of the curve, and in that case the coordinates will be used, the letters of the coordinates will be h and k. So this is the lowest value of the function. there's no greatest value. So as you move to the right along x-axis, you will generate higher and higher y values. If you move to the left along x-axis, you will generate higher and higher y values as well. So that means there is no restrictions in terms of x values. So the input can be any real number. So the domain for a quadratic equation will be set of real values of set without any limitation. So x is element of R. Now, the domain is well established. I have to change this. This is a little messy. So x is element of R. Okay, maybe this is better. The domain has no restrictions. Any real value works. In terms of the range, so as we have noticed on this graph here, we have the lowest value. So there is an x value such that y is the minimum. So that would imply that the range begins from this value of k and goes up. So y has to be greater or equal to whatever the value of k is. So the range is just the coverage along y-axis such that y is real, but with the limitation. Y is element of R, and y is greater or equal to k. I didn't fit that, so having trouble with my pen today. So y is greater or equal to k. So this is not the entire set of real numbers for the range. The domain is still the entire set of real numbers, no restrictions. The range, however, already has some restrictions. Now, if you were to consider a graph where coefficient A is less than 0, if A was less than 0, you would anticipate the reflection of the graph like so. So this value, the peak value, would be the highest value on the entire curve. So coordinates h and k, okay, so the domain is still the same, no restrictions. But the range for this type of function will be the set of real numbers. So you would say the range consists of real values. So y is element of R. Such that y is less or equal to k. So k represents the y coordinates of the vertex. So you either have a situation where you greater or equal than all y values if your vertex represents a minimum. When your vertex represents a maximum, then the range begins from the maximum value and all other numbers are less than the value of k. So to summarize, for any linear type of function, the domain and range represents real numbers, no restrictions, no limits. So this is for any type of linear function. When it comes to a quadratic function, just know that domain has no restrictions. Domain works well, which means any value of x can be selected and that will give you y output. However, the range has its limitation, and this is connected to the location of the vertex. You either have all values that are greater than the value of the vertex or less than the values of the vertex. Thank you for watching this video, and I see you next time. We'll discuss different type of functions, their domain and range.